Hi, welcome back to Science 1206, the Weather Dynamics Unit. I'm Ms. Ledwell, and in this video, we'll talk about atmospheric pressure. Let's get started. Atmospheric pressure, or air pressure, is the pressure exerted by the air on its surroundings due to the weight of the air. The SI unit for atmospheric pressure is the Pascal, with the symbol capital P lowercase a. In this diagram, it shows the pressure at sea level versus the pressure on top of a cliff. Notice the units here are HPA, which stands for hectopascal. 1 hectopascal is equal to 100 pascals. Also notice the difference in the two pressures. At sea level, it's 1030 hectopascals versus on top of the cliff, it's 930 hectopascals. So what do you think the relationship is between air pressure and altitude? If you said the air pressure is lower with increasing altitude, you're right. Atmospheric pressure is important in this course because changes in atmospheric pressure impact the weather, which is the topic we're studying. Remember that matter is anything that has mass and takes up space. Air is matter, and Earth's gravity pulls all matter, including air, toward the center of Earth. Atmospheric pressure is higher at Earth's surface and decreases as you go higher into the atmosphere. Closer to sea level, there's more air above us, and gravity pulls it all towards Earth's center, creating higher atmospheric pressure. As we climb higher, whether it's a hill, a mountain, or flying high in an airplane, atmospheric pressure starts to lower. The molecules in the air are more spread out, so the air is less dense, and fewer air molecules are pulling down due to gravity. Factors that affect atmospheric pressure include altitude, temperature, and humidity. As altitude increases, the atmospheric pressure decreases. The atmospheric pressure on top of a mountain, for example, would be lower than the atmospheric pressure at sea level. The atmospheric pressure in the outer regions of Earth's atmosphere is lower than the atmospheric pressure in the troposphere, the layer of the atmosphere closest to Earth. Let's look at the atmospheric pressure when the altitude is 10 kilometers. When the altitude is 10 kilometers, the air pressure is about 25 kilopascals. Now let's look at the atmospheric pressure when the altitude is about 95 kilometers. Here the atmospheric pressure is 0.0001 kilopascals. So notice that with increasing altitude, the atmospheric pressure decreases. At higher altitudes, not only does atmospheric pressure drop, but air density becomes lower as well. There's more space between the molecules of air at higher altitudes. Again, if we look at the diagram, at an altitude of 0 kilometers, the density is 1.225 kilograms per meters cubed. Compare that to when the altitude is approaching 100 kilometers, the density is 0.000001 kilograms per meter cubed. Next, let's look at the relationship between temperature and atmospheric pressure. Remember that density describes how closely packed together the molecules are in a material. Cold air is denser than warm air, which means that the molecules that make up cold air are closer together. As a result of the molecules being closer together, cold air exerts more atmospheric pressure than warm air. When a mass of warm air advances and replaces an area of cold air near the ground, the atmospheric pressure in that location decreases. Conversely, when a body of cold air pushes into and takes the place of a warmer region of air, the atmospheric pressure in that location increases. So to recap, when we look at cold temperature air, the molecules are closer together than in warm air, it is more dense, and it exerts more atmospheric pressure. When we look at warm temperature air, the molecules are further apart compared to cold air, the air is less dense, and it exerts less atmospheric pressure. The diagrams side by side show that in cold temperature air, the molecules are closer together, and in warm temperature air, the molecules are further apart. Now we'll look at the relationship between humidity and atmospheric pressure. Remember that humidity is a measurement that describes the amount of water vapor in the air. Humid air exerts less atmospheric pressure than dry air. As water vapor is added to the air, it displaces an equal amount of dry air. Water vapor is a lighter gas than oxygen and nitrogen gases, which are the main components of air. Therefore, air that contains more water vapor will exert less atmospheric pressure compared to drier air. Meteorologists rely on measurements of atmospheric pressure to forecast shifts in weather patterns. When atmospheric pressure drops, it often indicates the arrival of warmer, more humid air and an increase in temperature. Conversely, a rise in the atmospheric pressure generally indicates cooler, drier weather conditions are approaching. Now it's time to continue to the next video. Before you do, take a 30-second break, stand up and stretch, then continue on to the next video.